Hello folks, let's begin our today's topic, which is explanation of OR gate and AND gate using diodes and also using this circuit with switches. Now the symbol of OR gate is like that, where A and B both are inputs and Y is output, and the Boolean expression for an OR operation is represented as Y is equal to A plus B and read as A or B. We write it as plus but read as OR. Now the truth table of OR gate is this, where we can see that if both of the inputs are 0, then output will be 0. If one of the input is 1, then the output will be 1, and if both of the inputs are 1, then the output will be inevitably 1. Now in this circuit, it is quite easy to understand that this is a battery, these two are switches A and B, and this is a light bulb which will glow if current passes through it. But if the batteries are open like this, then no current will pass through them. If they are closed, if both of them are closed or any one of them are closed, then current will pass through them, and in that case the bulb will glow and we will get the output as 1. So in the first row, both of them are open, both of the switches are open, so no current passes through the bulb and the bulb doesn't glow. We get the output as 0. In the second row, A is open, A switch is open, B switch is closed, so current passes through this path and the bulb glows and we get output as 1. In the third row, we see that A is closed, B is open, so current passes through this path and the bulb glows. And fourth row, both of the switches are closed, so current passes through both of them and the bulb glows and we get 1 as output. Now diode, using diodes we can explain this, but I have a better representation which is better to understand and better to remember. This here, okay, here we can imagine a voltmeter across this resistor R, which will measure the voltage drop across this resistor. Now here are some rules. For logic 0 we get voltage 0 volt to 0.8 volt. For logic 1 we get voltage 3 volt to 5 volt, and for first row, when A and B both are 0, no current passes through this circuit and the output we get is 0, inevitably 0. Now the second row, A is 0, B is 1. That means we connect A terminal with ground and B terminal with battery, and current passes through this, but current does not pass through this diode, and 0.7 for silicon diodes, 0.7 voltage drop appears here, and the rest of the voltage drop we get from across this resistance, which is approximately 4.3 volt, and which is measured as high. From this chart we can see. So this is 4.3 volt across voltage drop across the resistance, and I am terrible at writing, and so we get output as high. We can understand this. The same thing happens for the third row, but A becomes 1 and B becomes 0. But for the last row, what happens is the same thing happens, but for both A and B. A is also 1, B is also 1. So current passes in forward bias, current passes through both of them, and then current passes through this resistance, and in turn we'll get the output as high. Okay, because both of them, they have their forward diode voltage 0.7 volt, which will drop across these two diodes 0.7 volt for silicon diodes, and the rest of the voltage we get from here, rest of the voltage will get across this resistance, which will be enough to declare this logic as 1. So this we can understand. Now come back to AND gate. Here the symbol of AND gate is this: A and B, these two are inputs, Y is output, and the Boolean expression for the AND operation is represented as Y is equal to A dot B and raised as A and B. Now this is the truth table for AND gate, where we can see for both of the inputs 0, output will be 0. If one of the inputs are 1, other one is 0, still the outputs will be 0, and only when both of the inputs are 1, the output will be 1. Now this is explained in this circuit. A and B both are switches. This is the light bulb, this is the battery. If A and B both are open, like in this first row, then no current will pass, so the bulb will be turned off. It will not glow and we will get the output as 0. If A is open, B is closed, still no current will pass, we will get the output as 0. If B is open, A is closed, still the current will get stuck here. It will not conduct through the bulb, we will get the output as 0. Only when A and B, both of the switches are closed, current will pass through the bulb, and inevitably we get the output as 1. The bulb will glow. Now about the diode circuit. This is a better circuit for AND gate, and here same rule will follow for the logics. And for when A and B both are 0, what will happen then? Okay, now here is the output. This voltmeter will measure the voltage drop across these two diodes. Remind that this voltmeter will measure voltage drop across these two diodes and not across this resistor. It is connected, this terminal is connected to the battery, which is like 5 volt, and these two can be alternatively connected to either ground or battery to give it high and low voltage, 0 or 1 logic state. Now for the first case, when A and B both are 0, then we'll get this, both of the diodes will be in forward bias, and because here it is 5 volt and in here, in this side it is high voltage, in this side it is 0 voltage, so it will, both of the diodes will be in forward bias and current will pass through them, and in turn we'll get nearly 0.7 voltage drop across both of the diodes, so we'll get the output as 0. Now for the second row, we will get A is 0, A is connected to the ground and B is connected to 5 volt, that means it is high, so this will be in forward bias, this will be in reverse bias, no current will pass through this diode, and because this will be in 5 volt directly connected to 5 volt, but in this side it will, this 5 volt will lose some voltage here across this resistance, and it will be here in some in low voltage compared with this side. So it will, this diode will be in reverse bias and it will not pass current. Now current will go through this path, and in turn we'll get the output across this output. That means the voltage drop across this diode will be 0.7 volt, nearly 0.7 volt for silicon diodes, and that will be 0. And the same thing will repeat for this third row. A will be 1 and B will be 0 in the for the third row. The same thing will repeat, you can understand. And for the final and fourth row, I'll show you. This is somewhat interesting. For the final and the fourth row, both of them are 1 1. That means both of them are in reverse bias, so no current passes through both of the diodes. And what happens, this 5 volt, no current passes through both of the diodes. This 5 volt directly gets connected, and this 5 volt, we can get 5 volt as output directly, as there is no current flowing through this circuit. No current will flow through this resistance, and we'll directly get 5 volt as output, which is high. So like this, it is explained how AND gate and OR gate are used, made, and explained using diodes. Thank you for watching. Please share the video and like and subscribe to this channel.